Okay. So let's move on to making the crawler. We're going to be working with the script titled RDG, and it's here, basically. Okay. So first of all, we're going to implement, I guess, the step function. As a quick reminder, basically we're going to start at the origin and then take a random step. Again, I think I made that clear, maybe. So if we look at the constructor for this crawler class, it's here. We have a variable that is a vector2 int, so basically like a coordinate, called current position, and this is going to be initialized at the origin, the original position, which is 0, 0. After that, we have something called num steps. So we're gonna, like, for each time we call this crawler class, we're gonna have a randomized number of rooms between an upper and a lower bound that we're going to specify here later when we construct this class. So for example, if the valid number of rooms is between 3 and 7, we could have, like, I don't know, 4 rooms in one crawl, 6 rooms in another, just to make, I guess, the dungeon more interesting or more random. So what we want to do here is simply, I guess, choose a new direction and then add this to the current position each time we call this step function. And the way I did it here was by calling random.range twice. So we get random.range basically, I guess it generates a random integer from 0 to 2, inclusive, exclusive. So here the two choices are 0 and 1, and again here. And the way I did it was that the first axis, if we generated 0, we would be moving horizontally. 1, we would be moving vertically. And the second one for direction, if we generated 0, we'd be moving in the negative direction, whether that's in the X or Y is specified in axis. And if it's positive 1, then we go into the positive direction. You can code this any way you want. You could have like one random.range between 0 inclusive and 5 exclusive, and just like for each of the 4 numbers have a different direction that you want to go in. But I just did it this way because I don't know, I like it better. Okay, so if we go here, you guys can code along. I'm just gonna type this. Oh, and if you guys have questions, just you can interrupt me now or sometime. Does anybody have questions? Or should I? Okay. And then also I returned a vector2 int .0 for the outline of this function, but then change it to curve pos because this is what we want to return. Okay, is everybody finished with this? I'll take that as a yes. Okay. So again, as a recap, all we did here was to find a random direction to step in and add that to current position, which is a method variable that we already have. So each time we call this, current position is gonna be a adjacent position to the previous current position. Yep. And then if we go here, I already have this written out. It's a public method that returns a vector2 int list called path. So every time, well, we're only going to call this once, I guess, for a crawler. So first we clear the list to make sure there are no like randomly initialized values. And then for the number of steps that we have taken, each time for each number of for the number of steps we have taken, we will like add a step to the path list here. So yeah, the path list here, and then we return that path. So essentially what we're doing is returning the list of connected coordinates that we generated here. Okay. And then after this, we're gonna move on to the second. Okay, so I combined both classes in this one script because the top one isn't a mono behavior class anyways. Okay. Wait, what? That isn't a mono behavior class, so they could be in the same script, basically. What we have here is that we have a serialized field of the number of crawlers that we have. I set this to 2, so we're gonna make this crawler class 2 times and generate 2 branching lists of coordinates, and the minimum number of steps that we can take is set to 6, while the maximum is set to 12. And then the 2 things we have here is a list of room coordinates and then a queue later. I'm gonna explain this later, so we don't need to worry about it right now. And okay, so we're gonna code this method right here, which is the generate coordinate list. What we want to do is basically repeat this twice. So for the number of crawlers, which is going to be 2, we're going to create a new crawler using the constructor that we had earlier that inputs the min steps over here and the max steps. And then we're going to concatenate the list that we generate into the room coordinates list here, which is going to be the entire list of all the coordinates that we're going to generate. So let's just do that first. Okay, I guess another thing that we should not be worried about, but that we should know is the toList function that we call here, because I guess the concat method that we're using to basically put this new list that we generated into the previous list room chord doesn't give us a list. It returns an enumerable thing in Unity. So we just need to add toList. Another option would be to, instead of using concat, to use add range, but this is the way I just did it here. So after this, what we have is basically in the room coordinates list, we're going to have a bunch of different coordinates that are going to be from the 2 previous paths or the steps that we generated with the 2 crawlers. But it's entirely possible that a coordinate would be in here twice. And we don't want that because we don't want to generate 2 rooms on top of each other, since that's obviously going to be very faulty. So what we do is we're going to sort of clean this list a bit by doing room chords distinct, yes. This basically removes all of the duplicate values that you find in the list of coordinates that we have. And then also we're gonna call this, let me just type, I can't talk while typing. Okay, this line, we're going to search through all of the entities in the list of room coordinates for ones that are the origin, and we're going to remove them. The reason behind this is that we want to manually put the 0, 0 coordinate at the very front of the list, so that when we load the rooms, the origin room or the start room is always going to be loaded first, so that we don't cause trouble when like the game starts but the like starting room doesn't load. So yeah, this is basically what we have. This function here, it's necessary, but I've already written it. So we have like, okay, we have I guess list room coordinates right now with distinct values of our rooms. But then the data structure we want to be working with here is a queue because it's first in, first out, and we want to load the first room first. So basically, we're just going to shove whatever we have here into a queue. To do that, we first clear the queue, and then we, like I said before, we want the starting room to be first. So we in queue manually the origin, the starting room 0, 0 at the first item in the queue. And then for each item we have in room coordinates, for each coordinate we have, we just simply enqueue it. And finally, we have this if statement here that's only going to be called once. So if this is the last element in room coordinates, so basically if it's the count -1, so the last one, and if it's not the starting room, if it's not the starting room, and also if we don't have, this is a flag variable earlier, we don't have an end room yet, we're gonna save the last coordinate as the end room. Again, start and end don't have functionality right now, but it's basically necessary because you probably want, like, I don't know, a boss in the end room and some like chests or items in the start room so your player can do stuff. So all we did was to save the last coordinate into like the end room chord here. All right, save that. And so far what we have, again, this is a recap, is a queue of rooms of a queue of coordinates that represent our rooms. And also we have saved in the end room coordinate variable the coordinate of the very last room. What we want to do now is to load the rooms, obviously. Again, the rooms are scenes that we already created. So at 0, 0, we want to load the start. We want to load, oh man. We want to load the start. Okay, wait. Did I? Okay. Oh my gosh, I forgot to type the S's. Okay. Whatever. I'll fix that later. So we want to load 0, 0 at the start. The start at 0, 0. We want to load the end room at whatever we have stored in our end room coordinate, and we want to have the empty room in all the other coordinates. After that, since all of the scenes are going to be loaded at the origin by default in Unity, we have to position all of the rooms to be in the right places. And then finally, we're going to open the doors that connect the rooms. And while doing this, we're going to move the rooms that we loaded from the queue into a list called loaded rooms, which is going to store all the loaded and positioned rooms, basically. Okay, so wait, does anybody have questions right now? Oh my gosh, I forgot to type the S's or something. What? Okay, does anybody still need to see this, or has anybody did everybody follow along already? If nobody says anything, I'm just gonna assume that. Okay. All right. Oh yeah, the code is in the slides in case you missed something. Thank you, Christian, for mentioning that. Okay, so again, to load the rooms, we're gonna need something called async operations and also coroutines. I think Richard talked about this in the advanced tutorials last quarter, but I'm gonna go over it again. So usually when you call a function in Unity, everything is going to be executed in that same frame. So this means that if you have a lot of things to execute, that frame is going to take very, very long, and your game is going to be like very laggy and with very low FPS. So with coroutines, you can spread the execution of a function between several frames. And to do this, you use yield return. So the coroutine is going to run in the background while your game continues doing whatever it's doing and update and everything. And the routine is going to finish when you call yield return. Usually we do yield return wait for seconds so that the function in the routine, like the code in the routine is finished after several seconds, or it returns after a specified amount of time. But here we're going to do something else because we're going to be incorporating this with async operations. So for our purposes right now, I think all we need to know is that async operations sort of also run in the background, and they have something called is done. So if you check is done on an async operation, it will tell you if the operation is finished, is done. So if we combine these two, we can make a coroutine that yields returns when whatever async operation in it is done. I think that makes sense. If you need more I guess information on working with multiple scenes in Unity, I suggest this video. It's pretty helpful. But for our purposes, that's all we need to know. And we also need to use the library scene management for this. And the async function we're going to use is called load scene async. It takes two parameters that we need. I mean, we need it to take two parameters. The first is room name, which is synonymous to scene name, because again, our rooms are going to be the three scenes: main, empty, and start. Start, empty, and end. And then the second parameter is load scene mode dot additive. Basically what this means is that you can have whatever scene you load isn't going to overwrite the previous scene you already have. So you can have multiple scenes. If you don't have this, then every time you load a new room, it's going to basically erase your previous room, and that is not desirable. Is this clear? Okay, I'm gonna assume it is. We're gonna be working with the room loader script right now. It's here. And if we look at it right now, I set this to be a singleton. Okay. I set this to be a singleton, which means that there's only going to be one instance of this script running in game, and that all other scripts can basically reference it with using the instance keyword. Not very important right now, but it's a way to, like, I guess, structure a hierarchy to structure your games. Okay, we're gonna work with this function called load room. So the parameter here is a vector2 int position, so a coordinate. So this coroutine, because it starts with our enumerator, is gonna take in a coordinate that we generated in our list and basically load the corresponding room. Again, if it's 0, 0, we load start. If it's whatever end room position is, we load the end room, and empty everywhere else. So to do this, I guess just an if statement would be fine. So here we have if the position is the 0 position, then all right, sorry, I forgot to mention this. We're going to use a variable called current load room type, which is here. So this, here, this is just a string that's going to be the name of the scene that we're currently interested in loading. For if it's 0, of course, we're going to load start. As you can see, this is exactly how I've written the name here, because this is how we're going to reference the scene. This else if statement here is gonna get the okay. All right, I forgot to mention this, but the RDG script that we were working with earlier and this room loader script are all attached to the same room controller game object. So then we can just access the RDG scripts and room coordinate that we saved earlier with get component. And this time it'll be the end room. And finally, we're just gonna load the empty room everywhere else. So this picks out the room, the name of the room that we want to load. And now we're just going to call the async operation by using async operation. Oh, also just to make this clear, we have this package right now. I mean, what library right now? So async operation. We're gonna name this operation load room OP. Well, it doesn't really matter, but. And then we're gonna call the function that we examined earlier, load scene async with, this is the name again that we set with this. And also, if you remember, load scene mode.additive. Yes. Okay, this is the operation that we're going to be, the async operation that we're going to be using. And, oh, this is just a placeholder, by the way, we're going to delete that, so ignore it. And then this is when we're using is done. So while load room operation dot is done equals false. So if it's not done, if this loading operation is not done, then what we want to do is yield return. Oh, let me delete this. What this means is that this coroutine is going to continue running in the background until the load scene async function is done. So it doesn't clog up whatever we're doing, and it doesn't stop like the frames from updating. It's going to run in the background until it's done. Yep. So now we just need to call this, and we're going to call it an update because we wanted to continuously load a room if we have unloaded rooms. So all right, there's a flag variable here, is loading room. This is going to be set to true every time we are loading a room. So if we're not loading a room, then also if, again, we're going to be referencing the RDG scripts here. So if the second if statement is if there are still coordinates left in our rooms queue. This is our list of all the coordinates list of all the room coordinates that we generated earlier again. So if there are still stuff left in here, then we just want to dequeue from that queue. I think we're familiar with queues, so yeah. This basically just takes since queues are first in, first out, FIFO, this will take the first element of the queue and dequeue it and store it here. So it's no longer going to exist in the queue, it's just going to exist in our variable here, which is a vector2 variable that is here, yes. And then set our flag to true. And finally, just since our load room function is a coroutine, we can't just call it with this syntax. We have to do start coroutine and then call that. And then we call, like, the parameter we give it would be per load room pause, which is the room we want to load. And that'll be it. So, okay, you'll notice probably that we never reset our flag variable, and we're gonna do this later, so just keep that in mind for now. And right now, did I type something wrong? Oh, whoops, my bad. Okay. If we run this right now, we have the start room loaded. I think I showed you this maybe, but save. But the start room is the one with the yellow circle. The end room is the one with the red circle, and empty, it just has no circle. The circle is just a visual indicator, so we know what the start room is and what the end room is. And yeah, again, if we go back to main and just run, all we're gonna have is a start room loaded, which is here, like the start room. And we can't do anything because the flag is never reset, so this is the only room that we're going to load. But we're going to change this later because we need to do something else right now, and that is to position the rooms. I mentioned earlier that in Unity, when you load a scene, it's automatically going to load at the origin, so all of our rooms are going to overlap even if you load it. So I guess the intuition here is of constructors. Sorry, did I miss a question in the chat? Oh, okay, nice. The intuition here is to use a constructor. So whenever we instantiate a room, we would put that into its like position in the coordinate grid. But then model behavior scripts can't have custom constructors, so we can't do that. But the solution is to make a function and call it manually in start, so it acts like a constructor, but isn't like technically a real constructor. And we're gonna do that in position room, which is in the load room, the room loader script that we are in right now. Here, as you can see, I made it so that it takes in a room parameter. Again, each room, if you recall, has this room script attached to it. And if we look at it, okay, this is just the size of the room in Unity's world space. So basically, the height is 15.7 units. The width and the height is 8.7. Because we're gonna have to translate the coordinate grid into Unity coordinates, right? Because the coordinate grid is basically just what we thought of in our head to envision like the stepping process. And then we also have variables to store the X and Y coordinates in the coordinate grid, like the 0, 1 thing. And yeah, yes, basically that. So what we're gonna do here is position the rooms accordingly. To do that, we can, okay, if we're gonna check if the coordinate is empty and take in the current load room position, which is what we set, over here by dequeuing. So this coordinate is going to be the coordinate that we're currently loading and hence positioning. This function right here, I already wrote it, is we're going to find in our loaded rooms list if the room with this coordinate exists. So basically, it's going to tell you if that room exists or if it's an empty space that with no room. So if it's not empty, if it's empty, because we don't want to load a room onto another room, technically you don't need this because we already checked in our previous lines over here to remove all of the duplicate values, but then this is just for, I don't know, extra security. So we're gonna set the room, which is this room. So the current room that we're trying to position, we're gonna set its transform to, we're gonna vector 3, which is gonna be okay. What we have here for the X coordinate, okay, here I'm talking in Unity coordinate system, not the coordinate system that we imagined earlier. So we're gonna have our coordinate times the width. So we're gonna displace it by that much. So to translate our coordinate into Unity's coordinate, basically. Does that make sense? I think. If not, just type something. And then we're gonna do the same for the y. So oh, also the dot x, if you don't know, just since this is a vector 2, this just accesses the x component, this accesses the y component. And we're gonna times that instead by room.height. And for z, we just want it to be 0. So this is gonna be our new position for the room. We're gonna set the position of the room to whatever this is. And we're also gonna set as parents to just to be sure. Yes. And then after that, this part isn't technically necessary, but it's gonna become useful later. So we're gonna set the name of the room equal to, as if you recall, this is gonna be either start empty or end, depending on what our coordinate is. So this is just gonna make it easier to recognize what room we are talking about in case you want to check what rooms you have already loaded. We're gonna name the room to be the type plus the x comma y, and then we're gonna set the room.x. Notice this is the uppercase x, so this is gonna be the x variable we have here that we just used to store information about the room. And this is the lowercase x because we want to access the vector component, the x component of this vector. Again, do the same thing for the y. And then after that, we just want to do loaded rooms dot add. Okay. Recap. We want to move every room that we loaded into the loaded rooms list, right? So this would be the list. And after we position each room, we would just add it to the loaded rooms list. And then, okay, if something already exists, we're going to do else. So if a room already exists in that position and we messed up earlier with the distinct, then we're just going to destroy goodbye room. Whatever game object this room is attached to, so the scene basically. And finally, we are going to set is loading room equal to false. So we can load the next room again. So this, if we go through the, is there a question? Plus sign. Hold on, did I? Oh, thank you, thank you. Yes. Okay. That should be good. So if you notice here, what we do is we only reset the flag variable after we position the room correctly. So after this is reset, in like the logic of the code, we would be moving on to the next room that we load. So basically start loading room, position room, load the next room. And then we're going to have to go back to the room script. If you recall, this position room thing is our fake constructor. So we're gonna have to call this in room.cs. We have to call this in the start function of room to make it act like a constructor that is called whenever a room is instantiated. So going to start, we would just add the line we go through the syntax room loader.instance because room loader is a singleton. I'm sorry for using singletons, but we reference it with the instance since there is only one instance, and then we call the position room function with the input of the parameter of this. So this room that we're calling. Oh, okay, nice. We like singletons now. Okay, that should be good for now. If we, oh my gosh. All right. So now if we go, wait, now if we press play, what we're gonna get is this. We're gonna have a start room, an end room, and a bunch of randomly generated rooms. This is what we want, basically. Oh my gosh, the zoom thing is so annoying. So to look at all of the rooms that we have generated, we have all of these here, and they correspond to all of this. And if we go to the room controller, and oh wait, never mind, I didn't set it to public, so we can't see it like that. So the loaded rooms, oh wait, it is here. The loaded rooms would have the 8 rooms that correspond to the 8 rooms here, and named accordingly since we added the name to it. And then if we run this again, every single time we're gonna get a valid dungeon that is different. So yeah, this is basically what happens. But then you'll notice that if we go back to game mode, we're trapped in this room because the room has like a polygon collider that corresponds exactly to this white wall, and our player has also has a collider, so we're trapped. So what we need to do now is opening the doors. Wait, okay, I forgot. Do we have questions? Okay, I'm not seeing anything, so I'll continue. As a recap, each door is if we go into empty, for example, each door there are 4 doors, which are all child components of room. And again, they have the enum of, they have the enum that signifies their type. So top, bottom, left, right. So we know which door to open and which to keep. And we're going to divide the process of opening doors into 2 steps, into 2 scripts, basically. So in the room script attached to each room, we have, we're going to store all 4 of these doors in a list. I'm too lazy to just make a list and then drag them in the Unity inspector. So we're going to do that via code, store 4 doors in a list, and then iterate through the list, opening whatever door has a room next to it. So if there is a room on the right of this current room, we open the right door and so on. And then the second part is in our room loader script. We want to only open the doors after all rooms are loaded. Because if you start opening doors whenever you load a new room, you're not gonna have access to all of the rooms that are gonna be there because maybe an adjacent room hasn't been loaded yet. So we're gonna only do this after all of the rooms are loaded. And yes, so starting with the first part of this, we're gonna go to the room script. And after positioning this room with the fake constructor, after positioning the room, we're gonna get all of the components that are doors. So doors, all right, and door, okay, oh my God. Doors is this array of door objects. Yeah, I think that's self-explanatory. So basically, since all of the doors are components in the what did I do? Okay, anyways, basically since all of the doors are, oh my gosh, are children of the door thing in the room game object, we're just gonna do get component in children. And wait, did I? Oh, my bad. Thank you, thank you. Oh my gosh. All right, we're good. Okay. This basically stores all of the doors in our doors array. And then we're gonna go to set doors. This is gonna be a tedious thing to do, but we're gonna iterate through the doors array. So for each door, and we'll call it D in doors, we're gonna switch D.type. Again, the type is just the corresponding position of the door that I already assigned. So for the case door, okay, let's just talk about this for now. So if the type is top, we're gonna use the isCoord_empty thing again that we had over here, basically checking if that coordinate has a room or not. So if it's not empty, if there is a room to the top of this current room, we're gonna open the door. And this just basically creates a coordinate that's top of this room. So y plus 1, but x is the same. We're gonna open the door, this door, and open door. What I did here was I set this color of the sprite renderer to transparent, clear, and then I disabled the box collider, so you can't see it. But I guess you can just disable the entire game object. But the caveat of that would be that if you wanted there to be, I don't know, hidden doors or something, that would make it different. So I just did this for now. And then break, of course. And then we will just repeat this for the 4 other directions. And then instead we will do -1 for bot and x -1 for left, and finally x plus 1 for right. Again, we're iterating through the 4 doors and door and checking if there is an adjacent room. That's basically all we're doing. So let's save this. And then now, wait, did everybody, I'm gonna give some time for people to finish this. Okay, it's in the slide, so if you need it. We're gonna move on to the second part of opening doors, which is to call this only after all the doors are loaded. So we can just go back to, where is it? Up, oh, oops. What? Okay, we can go back to room loader and go to the update function. So if we're not loading room, and this part will be called if we're still loading, we still have rooms to load. So the else would just be when we have no more rooms to load, when the rooms queue dot count will be equal to 0, or if the queue would be empty. So we can call else here, but I'm just gonna be sure, and we have a flag variable called door set. So if doors are not set, this is here, by the way, and it's initialized to false because we only want to open doors once and not be like continuously calling that function. We're simply going to, okay, so by now, again, all of the rooms that we need to load would already be in our loaded rooms list. So we can just access for each room in loaded rooms, right? We have room.setDoor. We just call the setDoor function on that room script. And then after we finish all of this, we just have to doors set equal to true. So we only call this once, and I believe that would be it. Okay, do we have questions? All right, then if we save this and if we go back, okay, I typed something wrong. Hold on. 40. Oh my gosh. There's an S. Wait, why do I keep missing S's today? What? Okay. Okay. Okay, now if we go back into main and oops, run it again, we have the doors correctly set. There are no doors leading to nowhere. And also all the rooms have doors that make it accessible. So let's go back to game mode and we can walk through it. But yeah, the camera is still dead. So we're gonna implement that next. Okay, camera movement. This would be, okay. We would be working with the camera controller script, which is in the main scene on the main camera already. So if we look at this, we have two fields. We have the room, current room. This is going to be set later to be, well, the current room that we are in. So the camera snaps to center on that room. And also the move speed, you can play with this. It's just how fast the camera snaps to a certain room. And basically we're gonna be working with this function. As you can see, if current room is equal to null, we're gonna just, I just did this debug.log message saying current room not set, and this is what's happening here. It's always being called because we haven't set it. What we're gonna do here is just, okay, let's just assume we already have current room set. We'll set that later. We just do, okay, sorry. We make a new position for the vector that we want to move to, which would be centered at the current room. Again, this is the position in Unity for the room, current room. And then set the Z to whatever Z we are on right now and move towards, move the camera towards this current room's position. So let's just do that. Okay, the last line, basically, we moved from this current position to the new position that we created in the time of time.delta time times camera speed. So this is the velocity, basically, of the move towards. Okay, now all that is left to do is to set current room. And I think I mentioned this earlier, but the room let's just go to this. The room prefab, I might have forgotten to mention this, has a box collider 2D. This is separate from the polygon collider we have on the walls, which is like the walls. It's the collider that maps the area inside the room. And I set this to is trigger. So we can basically use over here. I already created an on trigger stay 2D function. For people who are unfamiliar, this means that on trigger is called on trigger while whether it's enter, stay, or whatever, is called when two colliders collide, and when only one of them is set as a trigger. So in this case, our player has a collider that is not a trigger, and our area inside the room has a collider that is a trigger. So for stay, that just means if it's staying inside if the collider is continuing to be in contact. So all we need to do is, also the tag, I set the tag of the player to player so we can find it easily here. If you, wait, hold on. This is set to tag player. I already did that, so you don't need to worry about it. We just have to do if, oh wait. Again, this is a singleton. So we can reference it by instance, and camera, we just called camera controller dot instance, which is a singleton instance, dot cur room, which is our variable that we want to set, is equal to this, and that's all we need to do. So every time we're inside a room, we're gonna set current room to be this room. That's all this says. Okay, so finally, now if we play this, let me clear. And you'll stay inside, the camera will, it won't follow you because it's only snapping to rooms. But if you enter another room, it's gonna snap like that, basically. And then we're only getting this message twice because that's presumably when we haven't finished loading the rooms yet. Yes, and that is basically all the coding that we need to do today. So for now, this random dungeon generation algorithm is pretty simple because, well, it's just scenes that we're loading randomly. There are a few probably necessary ways to expand this. Firstly being, oops, wait, sorry. Okay. Firstly being, I guess, we want to spawn enemies randomly in these rooms, and that would be done within, since each room is a scene, that would be done within the scene. So there is nothing, the way we set this up, there's nothing you need to worry about for like positioning. You just treat that room as a scene in itself and do whatever you need to do in there. And if we have enemies, we probably want to close doors to avoid the player continuously running away from enemies and force them to fight. This could be done pretty easily by going to the door script, which is again attached onto every door. Currently, you only have one enum called type. I think what I did previously was add another enum and another variable called activation. We would just have a wall, which is basically no door, open and also closed. And you can set that accordingly. Another idea would be to have special rooms for example, a shop room, a loot room, and some hidden rooms where the doors wouldn't be immediately visible. And to do this, since we have 3 preset scenes right now, right? We have start, end, empty. Maybe you could add another one called shop or whatever, and just do what we did for the empty room. You would find a coordinate, and then instead of loading empty in it, you would load maybe shop, And then another idea would be constraints on room location. So right now, this is not usually the case because we always have the end room be the last room that we crawled to. But sometimes, very small chance though, you would have the end room spawn right next to the start room. For example, if like, I don't know, the crawler came back or something, that would be pretty undesirable for game progression. So a constraint on the boss room location. So basically the boss room can only be a certain amount of distance from the start room, or you can only access the boss room after you have traversed however many number of rooms or something. And then another very interesting one would be different room sizes or shapes. Currently we only have rectangles and that's kind of boring, but it's what Binding of Isaac and Moonlighter have. But you could always expand this. This would make the positioning of the room harder because you have to account for like the different sizes and shapes and always have them connect to doors. But I think it's doable. And finally, thank you, Richard, for this. We could disable current rooms for optimization purposes. And since we already have a variable storing current room, this would be pretty easy, I think. And then, okay. Oh yeah, and then finally, I listed 4 links over here, all YouTube videos that are videos that I found interesting to watch. The first one is the basis of my tutorial, but I feel like his code is really unnecessarily, I don't know, complex. So I re-implemented it in a simpler way, I feel like. The second one is a tutorial in Godot, I think. But it's very interesting because it has different, it uses a completely different algorithm that's more complex and has more math. And it generates a sort of cave-like room without regular rooms and incorporating different sizes. This one is just a random fun thing that I like. And finally, the last one has like, this is more for map generation, but random map generation, but it has basic graph theory and stuff. And it's also super interesting. Yes, and I guess finally, as a recap, we can just go over what we did. Firstly, we generated coordinates in a queue that are connected with the crawler, and then we loaded the scene using async operations and load room. Coroutines, and then after loading the scene, we positioned the room, opened the doors, and finally we implemented the camera movement. And I guess, yes, that would be it. Thank you for coming.